So let's begin. Who's my favorite student? Good old Anne. Number 1 says a current of 2 amps flows through resistor R1 as shown below. What's the current flowing through the 5 ohm resistor? Well, I guess I would label downhill, which is that way, that way. Current's going to be going that way. First thing I would look for are amps anywhere. Sean, do you see amps anywhere in this question on the circuit? No, but I always try that because if I can get current anywhere, that usually means I can get current everywhere. And once I have the total current, the question's going to fall apart. Then I'm going to see if I can use any of my Kirchhoff's laws. So Maya, what's the voltage from here to here? How many volts? What must the voltage be from here to here then? Also 8. Okay. Why does that help? Because up here, I know 2 things. I can find the current up here. It's going to be V over R. It's going to be 8 divided by 5, which I'm pretty sure is 1.6 amps, I think. Now they want in, oh, I'm done. I could have also asked for the what the current was in R2. It must be 0.4 amps. I could have given you the same question and asked you to find R2. It would be 8 divided by 0.4. Could have given you the same question and asked for the power in R2. That would be V times I or I squared R or V squared over R, depending on what you have. Meanwhile, the answer is D, yes? Okay. So just giving you an idea of how I can take one diagram and mix and match this quite a bit. Can you find R1 from this? Nope, not enough information. I would need to tell you the total voltage first. If I told you it was hooked up to a 20-volt battery, well, then you could say we've used up 8 in each of these paths. This must be 12 volts. So I've used up all the voltage. And then you could also find the current, sorry, the resistance, because it's 12 volts, 2 amps. It would be a 6 ohm resistor. So once you have that information, remember, if you know 2 things, you know 4 things: power, current, resistance, and voltage. Any 2, you can find all 4. Found it? Took you a while, but you never gave up. There's probably going to be something like this on your test. These are nice, challenging thought puzzles. Now, the fact that it said they're identical means they all have the same resistance. I decided to let each of these be a nice number. I said, I'm going to let this be 2 ohms, 2 ohms, 2 ohms. I didn't want to let them be 1, because 1 ohm, when you do the resistance thing, 1 divided by 1 is 1. I might spot a pattern that isn't there. And in fact, what I'm envisioning then is voltage 2 ohms, but up here 4 ohms. Yes? How many volts are going through that mathematical 4 ohm resistor compared to the 2 ohm resistor? They're the same. All right. Voltage and current are the same for all 3 bulbs. The voltage is the same, but will you have the same current going through 4 ohms and 2 ohms? That's got to be wrong. The voltage, oh, we got one more late person. This is late person number, I've lost track. The current in light bulb Z is less than the current. So let's put a voltage here, and I'll put a nice voltage. I'll go 20 volts because I think 4 and 2 all go in evenly into 20. This must be 10 amps. This must be 5 amps. The current in Z is less than the current. No, the current in Z is bigger, so that's wrong. The current, you know what? I'm leaning towards C, but let's check. The voltage across Z is less than the voltage across light bulb X. No, light bulb X would be 10 volts and 10 volts because each of them would be splitting the 20 volts. So that's wrong. It's got to be C. Has to be C. And as you get good at these, Sean, can I ask you to lose the hoodie? I just can't tell if you got headphones in. I don't think you do, but you're in my grumpy place right now. Thanks, kiddo. You get good at these, you can do these without actually making up numbers, but when in doubt, make up some nice numbers. And usually 2 ohms or 5 ohms are nice resistor numbers to use because when you take their reciprocals, they're not yucky decimals. Now we get to the written section. I don't need to rewrite this section. How can I tell so fast? They gave me two things. I'm not going to need to go 1 over R parallel equals. I won't need to do any of that. It wants the total current leaving the battery. Okay, I'm going to start in that location right there. What can I find right there? I can find I. I is going to be 8.5 divided by 60. It's going to be a yucky number. I should have labeled downhill first, by the way. Downhill, 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 downhill. So the first thing I can find is, I opened the calculator twice, which is going to drain the memory. So there we go. 8.5 divided by 60. Okay. It's that 0.14167. I'll carry some extra sig figs because I'm going to use this. 0.14167 amps. Also, I can now use Kirchhoff's rules because if this section here is 8.5 volts, this must also be 8.5 volts, which means I can find the current in that section too. It's going to be 8.5 divided by 40. It's going to be 0.2125. I equals 0.2125. Why is that nice? Well, now I can tell you how many amps were flowing up here and how many amps are going through here because it's going to be I total and I total. So it's going to be 0.2125 plus 0.14167. I get a total current. I'm carrying some extra sig figs, so I don't want to be using this. I would try and avoid. I would definitely not round this off to 0.4, for example. 0.35417. 0.35417 amps. 0.35417 amps. How does that help me? I know two things. Now I can find the voltage up top. The voltage up top is going to be that number times 25, I times R. I have 8.85425. 8.85425 volts. How many volts in the bottom? It's going to be I times R. It's going to be 3.5417 volts. And now I'm good. I can ski. Well, first of all, total current leaving the battery, I answered a while ago. The total current leaving the battery was 0.2125 plus 0.14167, which was 0.354 amps. Is that correct, folks? Yep. So I would give you 3 marks if you got the right answer. In fact, the way I would mark this, I would give you probably 1 mark if I saw that number, 1 mark if I saw that current, and then 1 mark for cluing in that you add them together to get the total current. Okay? Then I'm guessing it wants the voltage of the battery. Yeah, now I'm good for the voltage of the battery because the voltage is going to be this ski run here. So it's going to be 8.854 plus 8.5 plus 3.54. I'll have to remember that. Let's see. It's going to be, the total is going to be 8.854 plus, I think that was one number, 8.5 even, plus 3.5417, plus 8.5, plus 3.5417, and I get 20.9 volts. Is that correct? So 4 marks for that. In terms of part marks, well, you can see I had to find 3 things. So I would give you in your diagram or somewhere where you showed work 1 mark for that, 1 mark for that, 1 mark for that, and then 1 mark for the answer. So I didn't need to rewrite that one because I had that crack in the armor. I knew 2 things. You know what? Same deal. I know 2 things. I'm pretty sure I don't need to rewrite this. I could probably use a similar approach. It wants the power loss through the 5 ohm resistor. I'll get there, but I think the first thing that I would do is I would find the current over here. Current is going to be 6 divided by 4.5. 1.33, repeating, amps. Okay. Move over a little bit and give myself a bit more room. There we go. Oh, 6 volts there. I also have 6 volts here. Sorry, I forgot to label downhill. Should have done that first. That's downhill. That's downhill. By the way, current is flowing up from the battery. What direction are electrons flowing in real life? Down from the battery. It's just, you can see why we decided to let current be positive. Just way easier to think downhill and losing as we go through. I can get the current here then as well. It's going to be 6 divided by 9. That's divided by 3, divided by 3. That's 0.667 amps, I believe. Yes? And I'm going to use a little digital ink magic just so that I don't get confused. I'm going to put that there so it's next to the resistor a little more clearly. How does that help me? Okay. Oh, I can find total current because the total current is going to be 0.667 plus 1.33. I think it works out to 2 even, doesn't it? Plus 0.666666. 1.9, yeah, 2 amps. Total current's 2 amps. And 2 amps. Now they wanted the power loss through the 5 ohm resistor. I'm technically done. I could find the voltage, but I know power is also I squared R from my formula sheet. And so it's going to be 2 squared times 5. 2 squared is 4 times 5. I think it's going to be 20 watts. So if you got that, 4 out of 4. Otherwise, I would give you 1 mark for finding that, 1 mark for realizing that's 6 volts, 1 mark for finding that. Actually, no, I would probably go not no marks for the 6 volts. I would give you 1 mark for finding I total and then 1 mark for the answer. Oh, suppose the 4.5 ohm resistor is removed. If the 5 ohm resistor is a light bulb, how does the brightness compare? What tells me brightness? Voltage? Current? Okay, I'm still interested in power. So I think I'm just going to kind of quickly resolve this and see if the new power is bigger than 20 watts, less than 20 watts, or the same. And I think really I'm interested in finding the current going through it. So if we remove this from the circuit, then what I would have is these 3 in series. So our total would just be 16 plus 9 plus 5. Let's see. Our total would be 16 plus 9 plus 5. 16 plus 9 plus 5 is, sorry, 31? Is that right? 30, isn't it? No, 30. Had me worried there. So that means I total is going to be V total over R total. It's going to be over 30. What was the voltage source? 48. 1.6 amps. Power equals I squared R equals 1.6 squared times, it was 5 ohms, right, Mr. Dueck? Going to be less, right? 12.8 watts, which is less than 20 watts, and I would circle dimmer. This is a little weird. We removed a bulb. You'd think that would leave more energy for the other bulb, but when you add resistors in parallel, you actually lower overall resistance and increase overall current. And because it's the total current going through this bulb, yeah, this would get dimmer, as would this bulb get dim. Thank you. As would this bulb get dim. So I would give you 1 mark for circling that. I would probably give you half mark for that, half mark for that, half mark for that, and a half mark for your conclusion. This quiz was out of, let's get rid of that. Nope, let's erase that, Mr. Dueck. Out of 16? So if you can give yourself a lovely score out of 16, please, that would be lovely and wonderful.